Hello and welcome to today's PIR live event brought to you by Partners in Research Canada. My name is Stacey Joyce and I'll be your host. Remember that you can ask questions anytime throughout the presentation or the Q&A at the end by clicking chat near the top left of your screen. Make sure you switch the to field to everyone rather than all panelists, and make sure you mention your name, your school name, or your city so we can give you a shout out when we ask your question. Today's guest is Dr. David Wood. David is a professor of renewable energy in the Department of Mechanical and Manufacturing Engineering at the University of Calgary. Thanks so much for joining us. Excuse me, I better let you take it away.
Thank you very much, Stacey. So I will share my screen.
Please do.
And find my presentation and share that. So now I'll launch my presentation. There we go. Okay, how's that?
Perfect.
Okay, well, welcome everyone. Stacey has asked me to talk to you about renewable energy. My experience and expertise in renewable energy is mainly in wind energy, and because I don't have very long to talk to you about renewable energy, I thought I would concentrate on wind energy. But if you have any questions about other forms of renewable energy, then please feel free to ask them at any time in the presentation. So there's my title slide, which tells you who I am and where I come from. And I thought the easiest way to introduce the idea of wind energy or how wind turbines work is to look at them in comparison to an aircraft. I'm sorry that my screen, my presentation is advancing without me knowing. If you think about how an aircraft flies up in the air, it does so because the wings generate a lift. Which I've shown in this slide here. Each wing generates a lift, and that lift counteracts the weight of the aircraft and the passengers. So when you see an aircraft flying overhead, you can think about the way in which the lift balances the weight of the aircraft and the passenger. If we apply a similar thought to wind turbines, the difference is that a wind turbine rotates. So on the left of my screen here, I have an image of a wind turbine looking from the direction of the wind. And then on the right, I have an image of a wind turbine looking from behind the wind turbine. And you can see almost in the middle of that image, what is called the nacelle. And the nacelle contains a generator. And the way in which a wind turbine works is that the blades of the wind turbine obviously rotate, and they rotate because they generate lift in a very similar way to the way in which an aircraft wing generates lift. And the difference is that that lift causes the blades to rotate, and in the nacelle on top of the tower, as I pointed out, and I'll show you a diagram later, there's a generator that turns that rotational motion into electrical energy. And so that's a very simple and I think a very useful way of looking at how a wind turbine works. So the blades are, very roughly speaking, are rotating wings. And if you look at, on the next slide, a diagram on the top left about an airfoil, and the purpose of the airfoil is to produce a lift, the blue arrow acting upwards on that slide. The airflow over that airfoil gets deflected down, and there's a lift on that airfoil. If you look at a section through a wind turbine blade, and you can see that on the bottom right of the screen, don't worry too much about all the details of the structure of the blade, even though that's very interesting. It would take a long time to explain that in detail, but just look at the overall shape of that section through a wind turbine blade. It looks very much like an airfoil, and in fact it is an airfoil. So that reinforces the idea that there's a close relationship between aircraft wings and wind turbine blades. One of the really interesting things about wind turbines is that they're getting bigger and bigger all the time, and they've got substantially bigger even in the lifetime of you people listening to my presentation. So in 2012, you can see in the middle towards the left, typically a wind turbine maybe 160 meters tall. And then now, 2015, the biggest wind turbines are almost double that size. So wind turbines are getting bigger and bigger all the time. And the next image that I have, I think, shows that very graphically. So you can see here an aircraft at the top of the slide. That's probably a Boeing 747, but typical of a modern aircraft. You can see the Statue of Liberty there. You can see a football field there. And between those two, you can see a wind turbine very much on the left-hand side, very much like the ones that you've probably seen if you've driven past a wind farm. But if you go over to the right-hand side, you can see what is a very large wind turbine. And those very large wind turbines are usually designed and installed offshore locations, usually in Europe. And when you think of and look at how big and they are getting, it's pretty impressive. So there's a picture of what is currently the longest wind turbine blade in the world. It is over 88 meters long. And that's a pretty big number to get your head around. It's very difficult to accurately make those wind turbine blades, and it's very difficult to transport them to the site. So you can appreciate, I think, as wind turbines are getting larger and larger, there's a lot of issues just with the basic things of making the blades and getting those blades and the rest of the turbine to the wind farm to be installed. Now, the next picture that I have shows you the mould that is used to make a very long wind turbine blade. Not quite the biggest blade in the world, but almost that. So what you see there with the man standing in the mould on the left-hand side of the mould is a mould for half of a wind turbine blade. And most wind turbine blades are made in moulds like that. They're made out of fiberglass. So they're very similar in construction to a snowboard. If you've got a snowboard, then it looks, or it is made by a very similar process to what is used to make a wind turbine blade. So the blades are made in two halves, and then they're glued together, which is a very impressive sight to see. And with those big blades, you can probably appreciate it from the photo there. Once a blade has been made, and you can see a blade over towards the top left of the image there, you can actually walk up inside a blade. And that's a very impressive thing to be able to do. I've done it once at a blade factory in Denmark. Now, of course, the blades are extremely important to a wind turbine, just like a wing is extremely important to an aircraft. But there's a lot of other components to a wind turbine that we need to know a little bit about. So the final slide that I have to show you shows what is inside the nacelle on a wind turbine. So you can see on the top left of the screen that I'm highlighting now, there's the nacelle. The front end of the nacelle is where the blades and the hub attach to the nacelle. And then if we go down to the cutout picture below that, you can see on the left-hand side of that where the blades come in, there is what's called a main shaft bearing that takes the load on the blades. And then in the middle here is a very important component, which is called a gearbox. And that gearbox changes the speed of the shaft of the wind turbine, so that when it goes into the generator to produce electricity, which is unfortunately hidden by these blue components here, the generator behind what's labeled as a brake assembly is where the electricity is made. And one of the other features that's very interesting that you can see from this diagram here is you can see the yaw drive motors and this gear on the top of the tower that allows the turbine to be driven into the wind as the wind direction changes. So I think that, yes, that is the last slide that I have about what is inside a wind turbine, which you may not have seen before. So I think I'll stop there, and I'll take any questions that people have to ask.
Thank you very much for that. I had never seen the inside of the wind turbine before, so that's a really interesting image for me. I live in an area of Ontario that I drive past wind farms fairly frequently, but I've never seen the inside, so thank you.
Yes, it's very interesting. Yeah.
Okay, so what I will have you do now then is we'll get to some questions, and I'll ask you to just stop sharing your slides so that we can see your face just a little larger while you're speaking about the answers. Perfect.
Okay.
So questions are coming in fast and furious already, so I'll get going on the first one. Ms. Mark's class in Fergus, Ontario, they're wondering if wind turbines cause any problems for the creatures in the soil that live around the base of the wind turbine.
That's a very interesting question. There's some evidence that there might be some effect, because if you have a lot of wind turbines in a wind farm, that influences the wind flow over the ground of that wind farm. And I've seen a study that suggests that that might change the temperature of the soil very slightly. But so I think it's possible that that can happen, but I don't think there's any strong evidence that it's a serious problem with wind farms.
Excellent. Let's move on to a question from the grade 5s at St. Elizabeth Seton. They would like to know if wind turbines change direction when the wind changes direction.
Yes, very, very much so, because in most places where you put wind farms in, you get wind coming from all directions. And if I could just briefly go back to the last slide of my presentation.
Mm-hmm. Yep, you just have to click share once you get there.
Share is
at the bottom of the...
yes, share screen. Yep, okay. If you look closely, you can see I'm moving the cursor over the mechanism that does the change in what it's called yawing of the wind turbine. So you can see my cursor's just disappeared. There it is again. You can see what's called a pinion gear on the outside. That pinion gear that I'm running the cursor over is rigidly attached to the tower. And these two motors that are shown in blue, and there's two similar motors on the other side of the nacelle, which we can't see, those motors also have gears that engage that pinion gear and drive the top of the turbine around to face the wind. So there's a long answer to a short question.
Well, it's definitely not an easy answer, so that makes sense. Thank you for showing us that while you answered the question. Let's move to Mr. McCleary's class in Burford, Ontario. They would like to know, what are the wind turbines made of to make sure they are strong enough not to twist?
That's also a very good question, because as wind turbine blades get longer, it's harder and harder to make them structurally rigid. At the moment, wind turbine blades are made out of fiberglass, very similar to fiberglass construction that is used in things like snowboards. And so there is a resin that binds the fiber material, and the fiber material is selected to give strength mainly in the direction of the blade, because that is where the bending forces due to the wind act on the blade.
Okay. So we have a question now from Ms. Wolfson's class in Toronto, Ontario. They would like to know, what is better for generating power, wind turbines or solar panels?
Yes, these are really great questions. I hope you keep bringing them. It really depends on where you are in the world. because in some parts of the world that have a lot of sun and not much wind, solar systems are preferable. If you have a lot of wind and not much sun, then wind turbines are usually better. At the moment, for large-scale generation of electricity in sort of typical sites that we have in Canada, wind turbines are cheaper than solar photovoltaics. And that difference in the price will probably last for another 10 years or so. The price of photovoltaics, solar energy, is coming down, but it hasn't yet reached, for comparable resources, hasn't reached the price of wind energy.
Okay, so I'm sure that would play a role as well. Ms. Cook's class would like to know how many types of renewable energy are there? So we've talked about wind, we've talked about solar.
Yeah.
Are we missing some other types of renewable energy?
We're missing quite a few types. We're missing geothermal energy. And geothermal energy it usually requires drilling into the earth, that if you go down far enough, the temperatures can be high enough to do heating with them, just for space heating to keep us all warm in wintertime. And if the temperatures are significantly higher than that, they can be used to drive steam turbines to produce electricity. There's not many places in the world that have geothermal. New Zealand and Iceland are probably the main ones, but it can be a very good resource. One of the other big resources that is starting to be exploited is ocean energy. And the turbines that people are using to extract energy from the ocean, very similar to wind turbines. So they operate on very much the same principles. And there's a lot of potential energy there. But it's a very difficult environment to work in, because you need to build your systems to withstand very strong storms, and that's been one of the troubles with that technology. So they're examples of other forms of renewable energy, and more will come up over time. Some people think that hydropower is renewable. And Canada has a lot of hydropower. It certainly is to some extent, but sometimes there's a lot of environmental damage associated with hydropower. So some people argue that it should not be called sustainable, even if it is renewable. Some people think that nuclear energy is renewable. And again, that's arguable whether the byproducts in terms of the wastes are bad enough to label nuclear energy unsustainable. So,
right. So lots of different factors, and it sounds like it really matters who you ask for what the answer to that.
It does, and it also matters very much where you are. Because if you live in an area that doesn't have much wind, then it's very silly to consider wind turbines.
Right. Well, I'm going to stay on with the sort of general questions here. I just have to find an image. I have an image of a question to share with you. So we have Griffin is either a grade 2 or 3 student in Ms. Zorzetto's class, and this class would like to know, what is energy made of?
Oh, what a question. I'm not sure that I can answer that very, very easily, because energy is not something that you can see. If you take a bucket and fill it up with water, and then walk up the stairs of, say, a 3-story building, you will have increased the energy in that bucket. But if you look at the water in the bucket, you can't see that energy. And so it's very hard to actually visualize energy. And I think I've probably been using concepts of energy for so long that I've given up trying. I'm sorry, I don't think I can give you a better answer than that. It's a very good question.
Well, it's certainly a good description of the challenges in answering that question and understanding energy. So maybe now switching gears a little bit, I'd like to ask you a question from Ms. Montgomery's class. And they would like to know if wind turbines cause a problem for birds. We've also got some other people asking about wind turbines and do they give people headaches, or are there other health effects? And maybe in addition to that, are there any other disadvantages to wind turbines or challenges we have to overcome?
Yeah. There certainly have been cases where wind turbines have caused bird deaths, that they've been documented, but generally the number of birds that wind turbines have killed has been very small. And there's different ways that you can make comparisons between, say, birds that are killed by flying into skyscrapers, for example, birds that are killed by power lines. Compared to those things, overall, the number that are killed by wind turbines is very small. But there certainly have been situations, very specific situations, where wind farms either as they operate or as they are being planned, may cause damage to or hurt particular species of birds. And one of the areas that people are most concerned about here is with migrating birds. So if you have a wind farm in a migration path, then the birds that are migrating are probably not used to the wind turbines, and so they are less likely to be able to avoid them than, say, birds that are familiar with the turbines. In southern Alberta, where I live, we don't have any significant problems with birds, but we've had problems with bats. There's been quite a significant number of bats killed by wind turbines in southern Alberta, and that's been a particular issue here. They're also moving on to the question about illness. There have been claims that people are made ill by wind turbines. There's also been a lot of publicity for noise issues with wind turbines, and those two things are related. It's a very difficult issue to address because if you measure the noise output from a wind turbine on a wind farm, it's relatively small to many other sources of noise that we have, such as cars going along on the freeway. But there have been situations where possibly they have caused distress and illness, but it's a very difficult thing. As a scientist, I like to try and measure things objectively, and these levels are very low and very difficult to measure in any scientific way.
Interesting. So are there ongoing studies at all to determine if there are health?
There are a huge number of studies going on all over the world in all those issues: bird deaths, bat deaths, noise, and its effect on communities and individual people, and those illnesses that we mentioned. Yes, very much under study. One of the arguments in Europe for moving wind turbines offshore has been the noise issue. That as wind turbines get bigger, they make more noise, and so if you move them away from where people live, that's going to be less of a problem.
Right. Well, I'd like to move back to some more physical questions about the turbines themselves. We've got a lot of questions coming in about the making and the transportation of those turbines, etc. So let's maybe address some of those first. So how long does it take for a wind turbine to be manufactured, typically?
Ooh, that is a very good question. I don't really know the answer to that because I have only been let me start again. Usually the blades are made separately to the rest of the wind turbine. And so by visiting factories where the blades are made and then visiting factories where the turbines are made, it's very hard to combine the two pieces of information together and get a timeline. So my guess is probably about a month to make a wind turbine, but I have to emphasize that that's a guess.
Interesting. And then once it is made, how are the wind turbines delivered to the location they're going to be installed in?
Okay. Again, that's a interesting and difficult question. The blades are usually transported either by rail or long trucks. And that, of course, is an issue because the trucks have to go under bridges. If there's a bridge on the road, have to go around very sharp corners. And you can imagine carrying an 80-metre long blade that can't bend round a very sharp corner is a very difficult thing to do. The towers are usually easier to transport because the wind turbine towers are usually made in sections. And those sections are taken to the site of the wind farm and then welded together on the site to make the tower. And then once the tower is established, a crane lifts the nacelle up and puts it on top of the tower. And then when the blades arrive at the wind turbine, the 3 blades are connected together onto the hub, and then the crane lifts the entire rotor assembly, as it's called, up to the turbine and is connected that way. So it is quite a complex business where there's a lot of work going in getting them to site without damage. I do some work with a wind farm owner looking at the way in which the blades are eroded. The surface of the blades gets pitted by insect damage and dust and things like that. And we found in Calgary a wind turbine blade that was about 50 metres long that had been damaged during transportation. And it got very badly damaged. I'm not sure exactly how, but it more or less fell off the truck. And so that was a very expensive thing to do, because that blade is worth about $500,000. It's very expensive.
Wow, somebody must have been having a bad day after that happened.
Yeah, yes. The insurance company was not very happy.
So one more question in that realm. Ms. Cook's class would like to know, why do they only have 3 blades?
That's the other very good question. They could have 2 blades, they could have 4 blades, they could have 6 blades. Interestingly enough, the number of blades does not have a big impact on the amount of power that's produced. So if those wind turbines that I showed you in the presentation only had 2 blades, then they would produce the same amount of power, except the blades would have to rotate faster. And if the blades rotate faster, they produce more noise, and also they accumulate fatigue damage more rapidly. So in the selection of how many blades you put on a wind turbine, it's a very typical engineering decision where there are advantages and disadvantages in going from 2 to 3 to 4. But for a number of reasons, people have, or the engineers that work for wind turbine manufacturers have decided that 3 is the best number. There's a number of companies that are making very big wind turbines for offshore applications that have gone back to 2 blades, because obviously with 2 blades, the cost of the blades is cheaper than if you have 3 blades. But one of the other reasons that they use 3 blades is that if you look at a 3-bladed wind turbine rotating, it looks much nicer than a 2-bladed wind turbine rotating. So that's what's called an aesthetic reason for the choice. So when you get offshore, nobody's going to be looking at the turbines rotating so much, so they might use 2 blades instead.
That's very interesting, because I know one of the oppositions to wind farms close to residences is that a lot of people don't like the aesthetic. So I hadn't heard that before, that 3 blades is received better than 2.
Yes.
Interesting. Well, we are almost out of time. I'm going to squeeze in a couple more questions here. The grade 5s at St. Elizabeth Seton would like to know if fans and wind turbines work the same way, and are they made the same way?
Another excellent question. Yes, a fan is different in that it puts energy into the air. So the purpose of a fan for ventilation is to generate a movement of air. So it's opposite for a wind turbine, which takes the wind speed and produces power. So a fan uses power to produce wind. So they're sort of equal and opposite in that way. And aircraft propellers are also similar to fans. So, and the basic principle of operation is very similar. So if you remember the slide that I had showing the lift on the wind turbine blades generating power, if you just change the direction of those arrows, you would have the basic principles of operation of a fan. So yes, the blades of a fan do operate a little bit like wind turbine blades and aircraft wings.
I see. So basically, you use a wind turbine to take wind energy and turn it into electrical energy. And if you're using a fan, you're taking electrical energy and producing wind.
Yes, exactly.
Interesting.
It's neat, isn't it? Yes. Yeah.
So I'm going to wrap us up with one more question here from Ms. Mark's class in Fergus, Ontario. They'd like to know, what can kids do to help the world make a transition from fossil fuels to more renewable forms of energy?
A wonderful question to finish with. I think learning about the different types of energy is really important. So as you grow up, it's important to learn about all the other forms of energy and what we can do as a society to use them. And also, which I think is extremely important, we have to be very conscious of how we use energy. I think my view is that in Western society, we use far too much energy. So we have to be careful all the time to minimize our use of energy. So using compact fluorescent lights or LED lights, things like that, for energy efficiency are extremely important things to do. So it's a combination of learning about the different ways that we can produce electricity and energy without harming the world, at the same time as being aware of how you can reduce your consumption of energy. Excellent.
Well, I've got lots of messages coming in here saying thank you. I'd like to thank you so much, Dr. Wood, for joining us today.
Oh, I hope I've spread the message a little bit more. Thank you very much for the opportunity. And also thank you for those wonderful questions.
Great. Well, next week on PIR Live Event, we're talking about the Biochemistry Laboratory. More information on this and other upcoming PIR Live events are available at pirweb.org. Thanks so much for joining us, everybody. Have a great day.
Thank you. You too. Goodbye.